Hello. In this video, I will go over first order linear differential equations, and I will introduce the first order linear differential equations and how to solve this specific differential equations. I will also do an initial value problem. So let's talk about first order linear differential equations. So the last video was a separable differential equation. So let's look what is the difference? So a first order linear differential equation is one that can be written in the form of dy over dx plus p of x equals to q of x, where p and q are continuous functions of x on the given interval. So yeah, so it has to be in this form. That's how you know it's a first order linear differential equation. So let's look at example one. Let's determine whether the differential equation is linear. So, whoops, I kind of did this one. So we have y prime plus cosine of y equals tan of x. What I did was I replaced that y prime with dy dx, and you have a cosine. All right, let me erase this. Like, so yeah, y prime is dy dx. This is plus cosine of y. So what I would do is this almost looks like it's a linear differential equation, but unfortunately this cosine y does not have an x because it has to be, it would have worked if it was cosine of x times y, but it's just cosine of y, right? So it has to be a p of x equals q of x, so this is going to be no. Okay, what about b? We have x, y plus square root of x equals e to the x y prime. So what would I do first? Maybe, see, we can rearrange this. You can put this first and then move this to the right. So you can rearrange this as y prime e to the x equals to xy plus square root of x, correct? Then what I would do is replace this y prime with dy dx. Okay. Then what I would do is in order to put it in this form, I have to get dy dx by itself. So I have to get rid of this ex. To do so, I'm going to divide both sides by ex, everything by ex, right? Okay, so on the left, you're left with dy dx equals to xy over e to the x plus square root of x over ex. Okay, then what I would do next is, what do I do next? I'm gonna move this to the left because I somehow, yeah, I want to move this to the left. So I'm going to subtract this to the left. So I'm going to subtract xy or x e x y, right? So this cancels. So you're left with dy dx minus x ex y. And then on the right, you're left with square root of x. E to the x, right? Now, is this a linear differential equation? Yes, it is. Why? It's because this has a y in it, but you have an x, so that's good. So like on the other one, this should have had an x, right? So this, you have to have a y here, and then somehow you have to have an x here. And then on the right, this is all in terms of x, so that's good. So this whole thing right here is your p of x, and then this whole thing right here is your q of x. So yes to this. Okay, so let's go over the steps to solving a linear differential equation. So step one, write equation in standard form. So that's what you have to do. Step two, determine the p of x and the q of x. Okay. Step three, find the integrating factor. So to find the integrating factor is basically e raised to the integral of px dx. And I'll explain. Step four, put the final answer in this form. Y equals 1 over integral factor bracket integral of ix times q of x dx plus c. Okay, let's look at example 2. So we got to solve this differential equation. So first I'm going to put it in standard form. So y prime can be expressed as dy over dx equals to x plus 5y. And then what I would do next is move this 5y to the left because I want this to have a y in it. So I'm going to subtract 5y. This cancels. So you're left with dy dx minus 5y equals x. Okay. So now it is technically in standard form. Uh, your let's figure out p of x. Before we go in for let's figure out p of x and our q of x. Our p of x will be -5, and then my q of x will be x. Okay, the next step, since we have in standard form, we have our p of x and our q of x, find our integration form. So you're basically your your integrating factor. So it's I of x equals e and the integration of p of x d of x. So let's do that. Okay, so p of x is -5, and then you have a dx. So what is the integration of -5 dx? That is -5x. So it's we don't have to put the plus e. So it's just going to be e, and then this is going to be -5x. Okay, so this is our integrating factor form. So now we have to put it the last step, put final answer in this form. Okay, so do we have our I of x? Yes. Do we have our q of x? Yes. So we just put it into the equation. So it's 1 over I of x, which we said was e to the -5x. Integration, and then I of x times q of x, we said our I of x was e to the -5x. Times q of x, which we said was x, dx plus c bracket. Okay, so how do we take the integration of this part right here? How do we take the integration of that? Yes, if you said integration by parts, you're correct. Okay, so for integration of parts, if you forget, it's this formula. So we got to figure out our u and what our v is. So our u is x, and my dv is e to the negative 5x. So on here, our u is x, so our du dx is 1. And then we have to just get du by itself. So I'm going to get rid of this dx by multiplying both sides by dx. Okay, so I get du equals to 1 dx. And then I got to solve for v. So how would I do that? So to solve for v, I have to just take the integration of dv, right? Yeah, so it's just the integration of e to the negative 5 dx dx. I mean, e raised to the negative 5x dx. And how do we solve for this integration? Yes, you have to do u substitution. So our u is going to be negative 5x. Our du will be negative 5 dx. Now, is there something we have to get rid of? Yes, we have to get rid of this negative 5 because I don't have a constant negative 5. So to get rid of this negative 5, I'm going to multiply both sides by the reciprocal negative 5, negative 1/5. So this is negative 1/5 du, and then this is dx. And then you're going to replace dx with negative 1/5 du. Okay, so negative 1/5 is a constant, so it's going to be negative 1/5 e to the u du. And one is the integration of e to the u, it's just e to the u, and then you have that negative 1/5. So your v value is negative 1/5 e to the u, which is negative 5x. Okay, so that is my v. Maybe I should circle it, but that's not our answer. And we're still doing integration by parts. So it's uv minus integration of v du. Okay, so let's just continue. So what is our u? Our u is x. What is our v? My v is negative 1/5 e to the negative 5x minus the integration of v du. So my v is negative 1/5 e to the negative 5x. And then my du is dx. Okay. So over here, x times negative 1/5, you can kind of simplify it. That could be simplified as negative 1/5 x e to the negative 5x minus, what is it? Okay, so you have a constant here. Take it out. So you have e to the negative 5x dx. And what is the integration of, whoops, this I forgot, it's negative 1/5. There's two minuses, right? You took out a negative 1/5, so two minuses becomes a positive. Now, how do you take, what is the integration of e to the negative 5x? we did it before. It's negative 1/5. So the integration of this part right here is negative 1/5 e to the negative 5x. So you have a constant, so you could take it out. So it's plus 1/5. And then you also have a extra negative 1/5. And then it's just going to be e to the u, or in our case, negative 5x. Okay. Oh no, I'm running out of space. Okay. So I'm going to have to go sideways. Is that okay? So, so our, wait. Okay. So if you kind of simplify this part, this would be negative 1/5 x e to the negative 5x. And then what's 1/5 times negative 1/5? That's negative 125. E to the negative 5x. Okay, so now we can solve, right? So we're going to solve for y. So y equals 1 over e to the negative 5x, because it's 1 over, yeah. So it's, and then, hold on. So it's, yeah, negative 1 over e to the x, and then you said it was the integration of e to the negative 5x. And then we said right here, this, we solved it, which is basically this, right? So we can say it's y equals 1 over e to the negative 5x. And then this is going to be, we just replace this whole thing with this. Okay, and then you should just FOIL it out. So what's this times this? It's just going to be y equals negative 1/5 x, right? The e to the negative 5x cancels, so you're just left with x and then negative 1/5. And then what's this times this? That is negative 1 over 25, right? This e cancels, so you're just left with negative 125. And you also have to distribute it with the c. So that's going to be plus c times 1 over e to the negative 5x. Now, can you simplify this this e to the negative 5x? Yes, you can. It's like a complex fraction, so you can express this as 1 over, and then e to the negative 5x is 1 over e to the 5x. And then you multiply both sides by e to the 5x. So that's e to the 5x. And then this just becomes 1. Okay, so you can, this will be your final answer. Okay. Okay, let's move on to example 3. Solve the differential equation. So I have more space. So we have y prime plus y equals sin of e to the x. Is this in standard form? So step 1, figure out. Oh wait, actually, let's replace y prime with dy dx. And then this has an invisible 1, so you can put a 1 here there. So is this in standard form? Yes, it is. Um, yeah, there's a 1 here, that's fine. So yeah, that it is in standard form. So the next step is figure out our p of x and our q of x. So my p of x is just this number 1, and my q of x is this whole thing right here. Okay. So now I'm going to find my integrating factor. So it's going to be I of x is e to the integral of p of x, which is 1 dx. And what is the integration of 1 dx? It is just x. So this just becomes e to the x. Okay, and then we put it in standard form. So it's 1 over integration factor e to the x, bracket, integration of px times q, px times q of x. Is that right? Yeah, no, I of x times q of x, sorry. So it's my I of x is e to the x, and then my q of x is sin, our q of x is sin of ex dx plus c, and then bracket. Okay, so what I would do is do this step. What is the integration of ex times sin of ex? Um, no, you do not have to do integration by factor. I think you can get away with it using u substitution. So I think we're going to use u as my e to the x, and my du. What's the derivative of e to the x? Just e to the x. And then don't forget the dx. So that would be sin of u. And then you're going to replace ex dx with du. Okay. And what is the integration of sin u? It is negative cosine u. And that's going to be negative cosine. And then we said u is e to the x. Perfect. Okay, so we just fixed this. We solved for this. The integration of e to the x times sin of e to the x dx is negative cosine ex. We still have to multiply that 1 over e to the x. Okay, so this FOILs out as negative cosine of e to the x. And then if I FOIL this out, this is going to be, don't forget the c, so you do have to FOIL out the c. That's c times 1 over e to the x. So that you can leave it like that, or you can say y equals negative cosine. Okay, so that's your final answer. So that one wasn't too bad because we just had to do u substitution. Okay, let's do an initial value problem. So example 4, solve the initial value problem where t times dy dt plus 2y equals t cubed, where t is greater than 0. And you have an initial value of y0, y1 equals 0. So that's like 1, 0, right? So first, I'm going to put it in standard form. So I would have to get rid of this t by dividing everything by t, right? Okay, so now you're left with dy over dt plus 2 over ty equals t cubed over t1 is t squared. Okay, so now what I would do is figure out my, not p of x, but my p of t. So my p of t is 2 over t. Yeah, and my q of t is t squared. Okay, so then find your integrating factor. So it is equal to e integration of pt, which is 2 over t dt. So wait, how do you take the integration of 2 over t dt? Well, 2 is a constant, so you could take that out. So now you're left with 1 over t dt, right? And then what is the integration of 1 over t? It's just the ln of absolute value of t. And then you have it. And then you still have this too. Do you have to put the absolute value? I don't think so because our t value is positive, so it doesn't matter. Uh, it doesn't matter because you have the absolute value, so it's you can say 2 ln of t. So this simplifies as e, and then this will be, and the integration of 2 over t dt is 2 ln of t. Is there something I can do even more? Yes, do you see this too? Remember when you're dealing with logs or natural log, if you have a 2 in front of the natural log, it's technically a power. So you can rewrite this as e to the ln of t squared. Okay. So then what I would do is there anything you can do cancel? Yes, you can cancel the e and the ln, so that just cancels. You're left with t squared. So your it is t squared. Okay, so it's going to be y equals 1 over it bracket integration of it times qt dt plus c. Okay, so it is t squared. It is t squared, and then our qt is, what is our qt? Our qt is t squared as well. dt plus c bracket. Okay, good. This is not too bad. Integration, what t squared times t squared is t4 dt. And what is the integration of t4 dt? That is just 1/5 t to the fifth, right? You can say y equals 1 over t squared, and then you can replace this with 1/5 t5 plus c. So that's y equals 1/5. T5 over T2 is T3. And then don't forget, you have to FOIL out this C. That's going to be C times 1 over T squared. Now, we have an initial value, right? we said that we have a condition of y1 equals 0, so we have a coordinate of 1, comma 0, right? But we do have to solve for c. 1 is your x, 0 will be your y. So replace y with 0, replace t with 1. 1 squared is 1, so you don't really have to do that. So this is going to be 1/5 times 1/3 is 1/5. C times 1 is c. And then solve for c, so you're going to subtract 1/5. Subtract 1/5. So c is negative 1/5. Okay, then, so your final answer is going to be y equals 1/5 e cubed plus my c value, which is negative 1/5, times it by 1 over e squared. This would be, so this part here is like saying, it's like a complex fraction. It's like saying negative 1/5 divided by t squared. And it's a complex fraction, so you can simplify that. Here's 1, here's 5, so my LCD is 5. So that would be negative 1 over 5t squared. Okay, so your final answer will be expressed as y equals 1/5 t cubed minus 1/5 t squared. Okay, so this is your final answer. Okay, let's do a last example. So to solve the initial value problem, we have parentheses x squared plus 1 dy dx plus 3x times y minus 1 equals 0, where we have a condition of y of 0 equals 2, or you could say 0, 2. So what would I do first is get dy dx by itself, so I would divide both sides by x squared plus 1. Okay, this cancels, so you're left with dy dx plus, what I should have done is FOIL this out first. This is 3xy minus 3x. No, oh my gosh. I think I should have, don't do that. Don't divide x squared plus 1 yet. What I would do is I should have FOIL out the left. Let me do that first. I mean, FOIL out the 3x times that. FOIL this out. This is 3xy minus 3x. 0. Okay, and then what you would do next is this, see, we have to have a y in the left side, so I have to move this negative 3x to the right. Okay, then I would get rid of this x squared plus 1 by dividing everything by x squared plus 1. Okay, so now you have this cancels, you're left with dy dx plus 3xy over x squared plus 1, and then this is 3x over x squared plus 1, right? Okay, now we have it in standard form. Now I'm going to figure out what's my p of x and my q of x. So you see this y, you could take it. You kind of like can factor it out a bit. So you can say times this times y. Okay, so my p of x is this whole thing. And then my q of x is 3x over x squared plus 1. Okay. Now let's find our integrating factor. My I of x is e integration of p of x, which is 3x over x squared plus 1 dx. How would you do the integration of this? You would do u substitution. So my u would be x squared plus 1, and then my du would be 2x dx. Then what I would do here is, you see this 3? It's a constant, take it out. And then now, as you can see, we have to get rid of this 2 because we don't have a 2 here. So I'm going to get rid of it. I'm multiplying both sides by the reciprocal of 2, which is 1/2. So it's 1/2 du. Well, this becomes x dx. So this becomes 3, and then it's u here. And then you're going to replace x dx with 1/2 du. And so 3 times 1/2 is 3/2. And then the integration of 1 over u is ln. Ln is absolute value u. And then you solve this 3/2. So this is going to be e raised to the 3/2 ln. You don't have to put the absolute value. You just say parentheses x squared plus 1. And then remember, when you have a number in front of a log or natural log, it's really a power. You can rewrite this as e to the ln of x squared plus 1 to the 3/2. Okay, and then what do you see? That cancels the ln and e, so you're just left with x squared plus 1 to the 3/2. Okay, so that is my I of x. So now we can put it in standard form. So it's y equals 1 over ix I of x times q of x d of x plus c bracket. I of x is x squared plus 1 to the 3/2 integration. And then I of x is, all right, my I of x is x squared plus 1 to the 3/2 times q of x, which is 3x over x squared plus 1 dx. Let's see. Okay, what can we do here? This part right here, we can rewrite it as x squared plus 1 3/2, and then maybe put the 3x front. And then on the bottom, it's x squared plus 1, and then you can put a 1. So, dx. Now, you can simplify this. X squared plus 1, they're the same base. So when you're dividing with the same base, you subtract the power. So what's 3/2 minus 1? or 2 over 2, that is 1/2. So you can rewrite this. The 3 is a constant. You can take that out if you like. And then you can replace, we can simplify this as x squared plus 1 to the 1/2 dx. So how do you take the integration of this? Yes, you said it, u substitution. So it'd be u is x squared plus 1, du is 2x dx. And then I have this 2 here, so I have to get rid of it because I don't need it. And how would I do that is get rid of the 2 by multiplying both sides by the reciprocal of 2, which is 1/2. So it's 1/2 du. And then this is x dx. And then x squared plus 1 is u to the 1/2. And then you can replace x dx with, oops, you don't need this. You can replace x dx with 1/2 du. So this is, and then there's a 3. So this is 3 times 1/2, which is 3 over 2. And then the integration of u to the 1/2 du. Okay, so what is the integration of u to the 1/2? It is 2/3 u to the 3/2. Right? So it's 2/3, and then our u is, what is our u? Our u is x squared plus 1 to the 1/2. And then you still have this 3/2. And then I guess the 2's and 3's cancels. Now, whoops, this should be a 3/2. So yeah, so now you have, so it's going to be y equals 1 over x squared plus 1 to the 3/2 bracket. And then we simplified this whole thing right here, right? We said that is going to be x squared plus 1 to the 3/2 plus c. Then you would FOIL this out. So what's 1 times this whole thing? See how the powers are the same. So this is on top, and then so this just becomes 1 plus, then don't forget about the c. So that's c times 1 over x squared plus 1 to the 3/2. And then you have y here. And then thing is, we have a conditional state. We have a value, so initial value. So we have a coordinate at 0, 2. We're going to have to solve for our y, I mean our c. I'm going to replace y with 2. And then it's 1 over, and my x is 0. So it's 0 squared plus 1 raised to the 3/2. That's just 1. So it's 2 equals 1 plus c. And then so solve for c, so subtract 1, you get c equals 1. Okay. So now our final answer will be y equals 1 plus 1 over x squared plus 1 raised to the 3/2. Okay, so that's my final answer. Yep, that wraps it up for this section. Okay, I'm going to let you go. Thank you.